system. So this is quite common in one of the final exam question. And you can see here we have this airplane, okay, as shown in the figure, and it has mass and also J, mass moment of inertia, and the center of gravity G here. This is the assumed direction is already given, where the X, vertical downward displacement, and theta goes clockwise rotation. Yeah, so here, as I always recommend, you always list down what are the values given from the problem. So I've included X direction and the direction of theta. If the questions does not give you this information, then you need to assume. You have to assume clearly in your solution. So then they also give you all these parameters. Okay, I've written it down. You can see that there's a distance A and B, and I also draw it in a form that we can understand, that we can so that we can easily draw the free body diagram as shown here. Yeah, so you can see that you do have the K1 and the K2. And also you have a distance of A here and distance of B, and you have the pivot point or the center of gravity G. Okay, so let us take a look how do we solve this problem. First, of course, you would want to get the equation of motion, the characteristic equation. So this is also actually part A is always EOM. I cropped that part because they ask you to use Lagrange, but here we want to use Newton's second law first. Yeah, then we want to find the natural frequencies. That means you want to get omega 1 and omega 2. Okay, it is important to know that if you deal with 2 degree of freedom system like this, it's slightly different than you would deal with the single degree of freedom previously, where you actually draw the bar according to the direction of your motion, assumed motion. But in 2 degree of freedom system, you need to find the relative displacement. Yeah, so in that case, you do not need to draw it in the same direction of your motion. You just need to draw straight. So basically you can see here it's just a straight bar. Yeah, I don't actually slant it any other way, because you will have to decide on the relative displacement. So that's the first thing that you need to take note. So let us work on how we determine the relative displacement. So you can see here you have K1 and K2, and this is your G. Okay, how do you determine the relative displacement? So for 2 degrees of freedom, it's easy. You just straight ahead assume your X to be positive, so that it's easy whether your expression is going to be X minus L theta or plus L theta. So let me go ahead and assume X is positive. Maybe that's the first step that you want to do. Assume positive X. Okay, then only you decide, then you check, which side has a negative direction of your L theta. Yeah? Then check direction of your theta. Alright, so in this case you can see if I assume positive, that means you know that in this case your X going down is positive. So I draw this arrowhead like this, so that I get positive X. You remember relative displacement? So you follow, because this direction X is positive. Okay, then you check the direction of theta. Okay, because your theta going clockwise. Yeah, Remember your relative displacement, you have to look at on the spring when you decide on the relative displacement. So this arrowhead for x is positive, then you look at the theta. So theta, you look at the same arrowhead and figure out the direction of theta. Okay, so basically you look at the arrowhead and you look at from this point to this arrowhead. So it's actually counterclockwise. So basically what you have is theta is going to be negative. So here you have negative theta. It's not just theta, but there's a distance there. So basically your A theta, yeah? Maybe it's more, normally it's L theta because the linear spring on a bar. So this one is A theta. It's negative because it's counterclockwise. So then do the same thing. Then you do the same thing for K2. Okay, so you can see the arrowhead is going downward like this, but from your point G to this arrowhead, okay, so it's actually clockwise. So it's good that it is positive then. So it's positive. So this side, the distance from here to here is B, positive B theta. So because it's clockwise. Once you have determine the direction, then only you draw action reaction because this arrow goes down. So this one has to go up. Okay. So same as this one, it goes up. So in terms of drawing the arrows, it will be easy this time for the 2 degrees of freedom. You automatically set K1 and K2 goes down because you want X to be positive. Yeah. So once you do that, then the third part is actually draw action reaction. Forces. So once you have that, then only you write the EOM. Yeah. Because you already have all the relative displacement. So I have also used a colored highlighter to show you the direction according to the arrowhead so that you can get the left hand side for K1 is negative and the right hand side K2 is positive clockwise. Okay, so now we want to write the equation of motion. So now when we want to write the equation of motion, we are just looking at the top part of it. So I already cropped that for you. So let me just rewrite. We actually haven't finished writing up the forces. So we have decided on the relative displacement just now. So that K1, you can write it as K1 x minus A theta. And this one is K2 x minus the x plus B theta. Okay. So when you write your EOM, so you are just looking at this part here, the top part. So you would have your, there are two equations because you have M and G. So you have to write mx, okay, double dot, equals to summation of forces, where you are looking at, we already choose going down is positive using your x direction. So your F is just your K, that is negative because both of them are going up. So we know that x is going down, so that's why you have with arrowheads going up, you get negative. Same as for K2, you get negative. Then you rearrange the terms in terms of x and in terms of theta. So basically, this is your first equation. Remember, for 2 degrees of freedom system, you have 2 equations. Yeah, so another equation. So for J, so now we are writing it for J theta. So for J, you have J theta double dot equals to a summation of moment. So clockwise is positive. So you can see now your arrowhead with respect to the pivot point, so it's basically goes positive in that sense, because it goes from here to here. Yeah, so that's why it's clockwise, so you get positive. Same as K2, you look at the arrowhead, so basically that arrowhead to the pivot point. Yeah, so that will also so this one is positive, this one is K2 is negative, okay, because it's counterclockwise. So then you rearrange the terms, you collect, you take note that when you write for moment, you have to times the distance. So A and B, the distance, because force, moment is equals to force times distance. So make sure you don't forget to times your distance here. Yeah. So when we rearrange, so finally we rearrange in terms of x and theta as such, so that we have everything now. These two equations we can write in terms of matrices. Yeah. So when we write in terms of matrices, it's easy. You just get all the coefficients together. So in this case, you have your x double dot and theta double dot, and also your x and theta. So if you actually substitute, if you rearrange in terms of matrix, you can see that you just collect all the terms. If you have x double dot and theta, so you can see you only have first equation m, the second equation is j, so you do not have, in the first equation you do not have theta double dot, so that's why here is 0. Yeah, that's why it's 0 here. So same as the second equation, you don't have anything related to x double dot, that's why it's 0. So then you go to the next one. For x, so you collect the terms for the first equation. You have k1 plus k2 here, and then your theta is k2b k1a. So from there you get the equation. So basically when you arrange all the terms, so the first row is for the first equation and the second row is for the second equation. So this is just coefficient for x, and this part here is coefficient for theta. Okay, then you go for the second equation. This is for x double dot and this is for theta double dot. There is nothing in the second equation with x double dot, that's why it's 0. And then you look at the coefficient for x. So for x you have k2. So this is how you write your matrix. Sorry, I made a slight mistake here. I've included a bracket. You're supposed to have a bracket here. Everything times theta. Okay, so that's what you have here. Everything times theta, related to theta. Yeah, so from there you just substitute the values, and you can get the answer for your matrix of the two equation of motion. Okay, thank you.